Okay, testing one, two, three, testing one, two, three. Okay, I hope this is recording. Okay, so this is the second part out of I don't know how many parts. But so okay, we used I use screen. We use that equation to solve this equation. Okay. We got y equals 13 minus 5x. Okay, because of this. Okay. Then we apply this to that equation here. Okay. And we got x equals 3. Okay, now I'm going to use x equals 3 to solve this equation here, okay? It's like a full circle here. Okay, and we're gonna get a coordinate in a second, okay? So I'm gonna keep the color green here. So then let's go ahead and solve for 5x plus y. 5x, sorry, I can't see the thing, that's why. Let's go ahead, do it right here. 5x plus y equals 13, okay? What did we say was x? X is 3. So let's go ahead and plug that in. 5 times 3 plus y equals 13, okay? Let's go ahead and solve. What's 5 times 3? 15. Plus y equals 13, okay? We need to get y by itself. What am I going to do? I'm going to subtract 15 on both sides. Great job. I know you guys are doing it. Guys, make sure that you're writing everything that I'm doing. I want your notebooks to look exactly like this, okay? We're left with y because this crosses out. Y equals, what's 13 minus 15, okay? This can be tricky for you guys sometimes. You have $13 and I take away 15, okay? You're going to be left with less than $0, okay? Uh, or you can think about it this way, 15 minus 13, but you carry the negative, okay? So think about it that way. 15 minus 13, okay? 2. Carry the negative, negative 2. Y equals negative 2. Okay, backtrack a little bit. We used 5x to solve this equation, okay? And we got x equals 3. Now, we're going to use what we got from here to finish that. You see the circle? You see that, okay? That's good, okay? That's very good. So, now these equations yield the solution 3 comma 2. Okay, I'm going to write this down. This yields 3 comma 3 comma negative 2. Okay, Mr. Polito, where did you get this from? Okay, this is our x and this is our y. Okay, what was our x? 3. What's our y? Negative 2. Okay, this is good. Let's continue. Okay, so um, sometimes you're not going to be told which equation to use to solve the other equation and vice versa. You always want to pick the equation that doesn't give you fractions because fractions are bad. We don't like fractions, okay? We always want to clear them. We always want to reduce them. Uh, Sometimes they work in our favor when they're mixed, but oftentimes they work in our favor when they're improper, even though they're called improper. Okay, so fractions can be overwhelming, but you know how to do this. Okay, so this took up a page, so I'm going to use up a new page. Okay, go ahead and go back to blue. So I have here, uh, we're still underneath consistent systems. Okay, so continue that. So we have 3x. I'm going to speed this up a bit. Got 3x minus 2y equals 1, and we got 5x minus 5 y equals 4. Okay, just making sure. 3x minus 2y equals 1. 5x minus 5y equals 4. Okay, this time I'm going to use this. I'm going to use this equation. Trying to get the perfect star. I'm going to use this equation to solve that. Okay, let's go ahead and do that. So here I'm going to get x by itself this time. Okay, let's go get an x by itself. Okay, so we're running into already an issue, but let's not fret. Go ahead and get rid of 5y since we're trying to get 5x by itself. We're going to subtract 5y. We're going to add 5y to both sides. Put a line underneath it. Okay, we're left with 5x. This crosses out equals 5y plus 4. If I pause, it's because I'm looking at my textbook. 5y plus 4. Okay, it's plus 4 because 4 is positive. Okay, and I want to keep this on the left side, the variable with the coefficient. Okay, so I wanted to get 5. I should have rewritten this down, but it's fine. Let's move on. Okay, so it's okay because I have a color coordinate. I have colored it in blue. So we know that's our original equation. So we got 5x plus 5x equals 5y plus 4. Okay, we need to get x by itself. Okay, how am I going to do that? Divide 5 on both sides. Okay, and this one goes for the whole equation. Okay, uh, so x equals 5 divided by 5, 1, so technically y, and then 4 divided by 5, 4 over 5, well, you can't do that, so it's just going to be plus 4 over 5, okay? I know, fractions, we don't like them, but we got to work with them, okay? So now we're left with x equals, put it green, we're left with x equals y plus 4 over 5. Now we're going to use this to go ahead and solve this equation. Okay, we're going to plug in for x. So let's go ahead and do that. I'm going to rewrite the equation here. 3x minus 2y equals 1. Okay, so I had found what my x is, so let's go ahead and plug it in. So 3 and then parentheses because we're plugging in a number or numbers and a variable. 3, okay, what's my x? Y plus 4 over 5, okay? Mr. Pluto, where'd you get that from? Right here, okay. So minus 2y equals 1, okay? Now, we don't have any x variables. That's good. So we're on the right track. Let's go ahead and distribute the 3 to the y and the 4 over 5, okay? So what's 3 times y? Well, it's 3y, okay? Plus, okay. So when it comes to multiplying a fraction with a whole number, there was a trick where you divide the number and the denominator, and you whatever you get from that, you multiply to the numerator. But here, you can't do that, okay? Uh, 3 can go into 5 only one time, but we're left with a remainder, so we can't do that. So the way we're going to do that is we're just going to put a 1 over underneath it, because 3 over 1 equals to 3. So, and then we're just going to multiply straight across. So it's 3 times 4, yeah, 12. And then 1 times 5, 5. So we're left with 3y plus 12 over 5 minus 2y equals 1, okay? Follow along, please. Make sure you're writing everything down. So we got 3y plus 12 over 5 minus 2y equal to 1. Okay, so we're running into something here. We want to get y by itself eventually, but we got two sets of y's, okay? No bueno, okay? No bueno, okay? Uh, so we're going to combine like terms, uh, being 3y and negative 2y. So 3 minus 2 is what? 1. 1y, or just y. So let's go ahead and rewrite that. Y equals, no, y plus 12 over 5 equals to 1. Okay, okay, this looks a lot better, and we can do this. Okay, uh, well, we need to get rid of 12 over 5. We need to get rid of 12 over 5 so we can get y by itself. Okay, I know, guys, it's overwhelming because we're subtracting, you know, fractions, and it can be overwhelming. But just bear with me, okay? Uh, y, we're left with y because 12 over 5 minus 12 over 5 is 0. Okay, so it's just y. Y equals 1 minus, because we subtracted 12 over 5 on both sides, uh, 1 minus 12 over 5. Okay. Okay, this looks a little weird, right? 1 minus 12 over 5. What's another way? So, I'll just tell you, because if I try to explain it, it might confuse you. Okay, I'm going to convert 1 into 5 over 5, okay? Because 5 divided by 5 is what? 1, okay? And I chose 5 because since we're subtracting fractions, they need to be, they need to have the same denominator, okay? If you had done 6 over 6, then you're cooked. That would have not worked. So I chose 5 because they need to be the same denominator, and 5 over 5 equals to 1. So let's go ahead and do this. So because they have the same denominator, uh, we can just subtract the numerator. Okay. So y equals, what's 5 minus 12? Okay, 5 minus 12. Negative 7 over 5. Let me fix that. Y equals negative 7 over 5. Okay, so that's our answer. Okay, we got y, okay, by itself. Now we need to get x by itself. And we're going to go back to the original equation that we started with, okay? Remember, it's a complete circle. So let's go ahead and go, we're going to use this equation. Let me use green. We're going to use this equation, what we started with, to solve for x, given our y. So let's go ahead and do that. Let me go ahead and rewrite that real quickly here. So what I said was 5x minus 5y equals to 4, okay? And we said that our y is negative 7 over 5. So 5x minus 5 times, what did I say was my y? Negative 7 over 5. Negative 7 over 5, close parentheses, equals to 4. Okay? I can multiply negative 5 to 7, and that we can use our trick. You could put a 1 over it and just, uh, do that, but then you'd have to reduce, which is not a bad thing. Maybe you could do that just to double check. But let's go ahead and rewrite our equation. 5x minus, okay, no, not minus. 5x, okay, what's negative 5 divided by 5? Okay, negative 1, okay, negative 1. Now, what's negative 1 times, so negative 5 divided by 5, okay? What is that? That is negative 1, okay? Positive and a negative divided, you get negative still, okay? So we got negative 1. And with what we get from there, then we multiply to the numerator. So negative 1 times negative 7 is what? Negative 1 times negative 7. It's positive 7. Plus 7 equals 4. Okay. This is looking a lot better. So much better. Okay. What are we going to do next? Okay. I need to get 5x by itself. Okay. I'm going to subtract 7 on both sides. We're left with 5x equals, what's 4 minus 7? Negative 3. Okay, 5x equals negative 3. Okay, I'm not done yet. I still need to get rid of negative 5. Still need to get rid of this 5 over here. So what am I going to do? Okay, I'm going to divide by 5. Why? Because the relationship between the 5 and x is multiplication, and we're going to do the opposite of that, and that is division. So this crosses out, and we're left with 5. We're left with x equals negative 3 over 5. Okay, so we got our x and we got our y. Okay, this is our x and this is our y. So my answer is going to be, this yields a solution of negative 3 over 5, comma, because it's a coordinate, negative 7 over 5, okay? Mr. Polito, how did you know to put it into coordinates? Because in a coordinate we got x, comma, y. And what's my x? Negative 3 over 5. What's my y? Negative 7 over 5. I will say the negative sign, maybe for your final answer, put it in between. It doesn't matter where you put it. It still means the same thing. I personally just like to keep it at the top. Um, it makes solving problems a lot easier. So this is it for that. This is it for solving systems by substitution with consistent systems. The next part is going to be inconsistent systems. You know what? I think I'm going to wrap it up with one more part, and I'm not going to get into inconsistent systems today. I know you're bummed out. I know. I'm so sorry. There's one more piece. It's the consistent part is kind of lengthy, and I think you already wrote enough. No, I think you can write more, but for the sake of a restful day, we won't get into inconsistent systems. But I am going to wrap up consistent systems with another video. So just let me just I'll stop here and I'll record another video.